Hello everyone, in this session we will be discussing the HGG interface. To access the command we need to go to project, import export, NC and HGG program data. The HGG interface is divided into different areas: info, macro and export. Info is usually used to preview or to run checks or info on the existing members. Macros is the area where you can configure and apply the macros on members. Export is the area where you can actually configure the parameters and you can export the information to the program data. We have taken the small example using which we can show you the different options of the HGG interface. First of all, I'll go to the plan view. If I want, I can run the macros in this view, which is the regular Bocad view, or else I can also create a separate view. I can go to single and I can select the member. So it will create a separate new view with all the connecting members. If I want, I can apply the macros here. The info is basically used for different checkings. If I want to check the existing information on a member, I can use this info and it will give me the information here if it has any program data. There are other checks which I'll be running later on. Let me go to the macros tab. The macros tab has various macros which you can use, that is chamfer, saddle, slot, hold on and hold in. Along with the macros, you also have cutting parameters here. You can have multiple cutting parameters here. For each and every macro you will have predefined cutting parameters, but also you can add your own parameters here. In this cutting parameters, we have various options like the maximum cutting angle, minimum cutting angle, shrinkage, root opening, bevel, etc. Let me apply a saddle macro. So first I'll go to the saddle macro. I'll select this. In the saddle macro, I also have some extra option which is like a slope option for AWS. I can specify the angle, minimum angle, beyond which it will be turning into a offshore saddle. Select the member and select both the members, which is connecting. Let me apply saddle macro for these two bracings. The way the interface works is that when you apply these macros, the information is stored in the member under the comments. You can see the various comment families here under which the information is stored. If you want to remove the information from a member, you can use the delete cuts option. In the delete cut, you have various options. All will delete all the information for all the macros. Left and right can be used only for chamfer and saddle. Basically, you can say you want to remove the saddle or chamfer information on the left side or the right side of the member. Holes and cutouts will remove all the holes information from the member. In the slot macro, we have various configurations available. We have configuration for oblong hole, rotated oblong hole and slotted hole. The difference between oblong hole and rotated and slotted oblong hole is that using an oblong hole you can apply the bevels only on the longer side of the member, but using the other two macros you can apply the bevels on the all sides of the member. So this is the oblong hole, and if I use a rotated oblong hole, I have two bevel options here. So let me apply the slot macro here first. I need to select the pipe and the plate. For the main pipe, I'll be using the rotated oblong hole. I have finished all the slotted hole macros. Now let me apply the hole in connections here. So for hole in, I have two options here: normal hole in and X bevel hole in. Let me apply the X bevel first. Using the X bevel, I can have two bevel angles, and using the field depths, I can mention that the first bevel of 45 degrees is till what depth, and the second bevel of 30 degrees should start from where. So let me apply this. And on the other side, I'll apply a normal bevel with hole in. Select the member and then now I applied the saddle, slot and hole in. Now remaining is the chamfer. So let me apply the chamfer. For the straight portions, if I want the straight edge to be with 45 degrees bevel, I can use the chamfer macro, where I have mentioned that I want 45 degrees bevel. Even in this portions, I need to apply those chamfer bevel. But here I will say without 45 degrees, I want straight cut. Now I applied the program data on all the information on the members. Now to verify it, I can go to info. I have two options here. I can say show the pipes without the program data and show the pipes with the program data. There is no pipe here which has a program, which doesn't have any program data. If I click here, it highlights all the pipes which has the program data. Also in info, we have something called get existing info from pipe, where I can say the drawing type should be pipe drawing. And if I select the member, it generates a drawing with all the information for the program along with the information here. Now let's run the marking process. Once the marking is done, I can go to export tab and I can do the export. For export, we have various options here. For output, you can have either a single file for the complete selection list, or you can have a single file by phase or by mark. For the version of program, there are two versions of program which we support, which is program 3.2 and program 5.1. Some of the latest macros which we have added are compatible with version 5.1, so I would recommend you to export in 5.1. Source tab. We have two options here in source, which is CAD current version and CAD specific name and version. By default it will be CAD current version, which means it will read whatever is the current version of Bocad you are using, and it will input that information in the PCD file. But for any reason, if you would like to change the version names in the exported program data, we can just select the CAD specific name and version. Now the program data is created. This is various information. You can go to different views. You can see the cuts here. We have two chamfers, one oblong hole, on this member you can see we have a offshore saddle and a oblong hole. The offshore saddle was because of the AWS switch. This hole was a X bevel, so that's the reason you can see there are two slopes here, bevel angles here. And this particular member had a normal hole in. That's all from me regarding the HGG interface.